Hi everyone, welcome back to our X-Chem YouTube channel. I'm Taylor, and today we'll be talking about polymers. Before we begin, I'd like to thank our sponsors, Actua and Promo Science, for funding these awesome opportunities. So, what is a polymer? Let's break it down. The word polymer is a combination of two words, poly meaning many, and mer meaning part, or parts. So a polymer is a structure built of many connecting parts. These parts are usually very small molecules, known as monomers, that all connect to one another and form a really long chain. So to demonstrate what I mean, think of like a chain of paper clips, and think of how they would all be connected when they're linked in, like a gold chain or that kind of thing. That's kind of what I mean when I'm talking about polymers. That's what they would look like if you just took them under a microscope, that kind of thing. So because of their strong links, polymers are often used as lightweight, durable, strong, and flexible materials. Often they're also cheaper to make, so plastics are one example of a polymer, whereas things like wood and metal and ceramics are not. So polymers come in two arrangements, crystalline and amorphous. So an amorphous arrangement means that the polymer chains are arranged within the structure in no particular order. They're all over the place. So polymers like plastic have this arrangement. A crystalline arrangement means that the polymer chains are arranged in a distinct pattern. So things like diamonds are crystalline. So where are polymers? The short answer is kind of absolutely everywhere. Polymers are in many, many different things, and we use them every day for almost everything, from making food to driving cars to building phones. There's two types of polymers found in our world. There's naturally made and synthetically or man-made. So natural polymers occur naturally in things like leather, our hair, cotton, and even our DNA. All of these structures are made of long polymer chains. But what we most commonly know polymers as is the synthetically made kind. Things like plastics, polystyrene or styrofoam, and glass and latex, that kind of thing. These structures we wouldn't find naturally. They're made by humans to work as tools for our benefit. So since we wanted them to be strong, long-lasting, and flexible, we designed them using polymers. So while these structures can be super useful, they can actually be pretty harmful to the environment. Since they're designed to be long-lasting, synthetic polymers have a habit of sticking around on our planet for hundreds of years before breaking down. So plastics are a major source of our pollution in landfills and in the sea. But we're now working on ways to bring down this pollution through recycling and getting rid of our single-use plastics. So things like shopping bags and water bottles are now being recycled into new items like t-shirts. So let's do some experiments with polymers now. So the first that we're going to look at is slime polymers. So if you remember that polymers are long chains of molecules, these chains can fall past and around each other normally to allow the substance to move freely. So we can make something known as cross-linking occur, which binds these chains together and locks them into place and stops them from moving so loosely. So this makes the substance stronger and self-cohesive. So we're going to make slime today to show that occurrence. So here I have the materials. And we're just going to walk through the experiment here. So I have a beaker, a cup would work fine. And what you want to do, you need to use Elmer's glue. Not any glue will work. And you just want to dump it in just so that the bottom of your cup is covered. Next, you just want to use a little bit of baking soda. So I got a big bag here, but we're only going to use a little. Just about a quarter of a teaspoon. So that should be good there. And now I'm going to add a couple drops of green food coloring because we're going to make green slime today, but yours can be whatever color you'd like. And now we're going to mix this up. And if you can see this, I'm not sure. But it's kind of a very liquidy solution right now. What we're going to do is add some contact solution, and that's going to just firm it right up. So a little bit of contact solution, and we'll start moving it around, mixing it up, and it starts to stick to itself. So it's forming the chain linking and becoming self-cohesive. So as you can see, we now have some slime. And I'm going to add a little more contact solution because I prefer less gooey slime. And this will just make it bind better to itself and bind less to you. So here we have our slime. It's very gooey. And you can just play with it as you will. It's very sticky right now, actually. So that's slime. That's our slimy polymer. So let's talk about why this works. The glue moves freely, and the polymer chains within the glue slide around one another without getting caught. But when I added the contact solution, it causes these chains to link together, and we get a tighter, more cohesive structure, like this. And in case you're wondering, the baking soda just works to kind of firm it up a little bit, so it's less, it won't fall apart as much the more baking soda you add. So let's move on. Something a little different. We're next going to talk about absorbent polymers. So the first one we have is something called sodium polyacrylate, which is sometimes called the diaper polymer. It's called this because it's used in diapers, pretty obvious. Sodium polyacrylate is super absorbent, so much so that when you add water to it, it soaks it all up and turns it into like a jelly-like substance, which is perfect for keeping diapers nice and dry. So let's see it in action. I have some here, and this, and I have some water in this beaker, and this beaker is just empty. I'm going to use it. Now, all we need is just a scoop. So I'm going to grab a scoop of this, and another little bit for good measure. And as you can see, the water is water. It's very liquidy. And we're just going to add it to this and stir it around a bit. And all of a sudden, it just turns into this jelly-like substance. And we can add more to it as well. And the more that you mix it, the better it will work, because sometimes sodium polyacrylate gets stuck underneath the gel that has already reacted. So I'm just going to mix it around a little bit. And we get kind of like this goopy, jelly-like substance. So that's basically how it works. And it can absorb a ton. If I add even more and mix it around, it's just going to keep reacting. And it's going to keep absorbing. And we can just keep tipping it upside down, and it will not pour out. We're almost out of water now. But slowly it does get saturated, so it's getting a little goopier now. I'm going to try to tip it down one more time. Hopefully it won't spill out everywhere. But we now have the whole beaker in here, and it's pretty goopy. So as you can see, there's no water left. And if I tip it upside down, it holds. So that's pretty cool. That's how diapers work, and that's what sodium polyacrylate does. But let's talk about why. It works basically because sodium acrylate, sodium polyacrylate is a polymer. Each monomer in the chain has a molecule of sodium attached to it, and when the water is added to this chain, it kind of displaces the sodium off of the monomers, and the water replaces it, and it makes the chain expand. So in this solution, we have a lot of loose sodium molecules, and the water is now part of the polymer chain. So I have another absorbent polymer here that works kind of similarly. It's called Insta-Snow for a pretty obvious reason, you'll see soon. It's a polymer that's widely used by products and companies when they can't use real snow. So places like skiing resorts may use them when it's too warm outside to keep real snow. And even in movie sets, they use Insta-Snow to make it look like it's actually snowing. So let's see what it does. I have a scoopful of some Insta-Snow here. And I'm just going to add it to the beaker. And as you can see, it's pretty dry stuff right now. But if we add our water, which we have right here, it's going to expand. So let's add the water. And let's just mix it around a little bit. And already you can see it's turning very fluffy, which is why I have this pie plate here, because it can get kind of messy. But it expands like crazy. And it just keeps expanding. The more that I mix it, the more it reacts. So that's Insta-Snow, which is instant snow. Now, one other thing that's kind of cool, so as you can see, it's very fluffy, snow-like. It works in a similar way that sodium polyacrylate does, where it had sodium molecules attached to the monomers, and then when we added water to it, displaced it, and the water got attached to it. But something cool, if we add that salt back, here's just table salt, it will displace the water again and replace it back on the monomers, and we'll get our chain restored, and the water will kind of restore itself as well, and we'll get some melting snow. So I'm going to put some salt on this, and I'm going to mix this around a bit. And as you can see, our Insta-Snow is starting to turn to slush, and it's starting to melt again. So it used to be very fluffy, but now it's almost liquid. See, I can pour it right out. So that's our absorbent polymers. Next, we have one more experiment to show about styrofoam. So remember earlier when we were talking about plastic and styrofoam pollution? Well, one way to get rid of styrofoam fast is to use acetone. So styrofoam is made up of a polymer called polystyrene, and it's a super versatile product. But these polymer chains are always arranged parallel to the length of the cup itself, and it can break down really quickly because of this. So I have some packing peanuts here. I'm going to just do that. I have some packing peanuts here, and I have a beaker and some acetone. So I'm going to add the acetone to the beaker. And these packing peanuts are made of polystyrene or styrofoam. And on its own, it would take hundreds of years to break down. But if we add it to the acetone, I'll just hold it up. It immediately dissolves. So if I were to add more, maybe a handful at once, it's all gone within seconds. So that's pretty cool. Let's talk about why this happens. This works because of a principle that we talked about in the previous video, like dissolves like. So polystyrene, the polymer in styrofoam, is a nonpolar substance, and acetone is also a nonpolar substance. So it breaks down really easily in acetone. But water, on the other hand, is a polar substance, and therefore it won't dissolve the styrofoam nearly as well as the acetone will. So that just about concludes our presentation on polymers today. Does anybody have any questions? And I'll just stick around for a little bit because there is a bit of delay. And actually, while I'm waiting, let's see if this acetone can dissolve a whole styrofoam cup. So, here I have a styrofoam cup, and we're just going to drop it in the acetone. Or let's break it in half first because it probably won't fit in the beaker. But we have this broken, and let's just dump it in. And as you can see, it's just quickly dissolving until there's nothing left. So let's add the other half. Swish it around a little bit. And just like that, the whole cup is gone. So it doesn't look like there's any questions. Yeah. So I guess we'll see you back tomorrow for a new live stream. So don't forget we have new live streams every Tuesday, Wednesday, and Thursday at 10 a.m. So thanks for watching. See you later.